Well, welcome everybody. Hi. Hi. So, my name is Mark Ettrich, and me with a couple other folks who we'll talk about in a minute. Can you flip the slide? I have these lovely pictures at the bottom, straight out of LinkedIn. So myself and
I only see one lovely picture. In your dreams.
So a couple months ago, we had the idea of trying to connect together in a conversation I had with Chris Lynch, who will be up here in a minute, talking about how we connect some of the big data work that's going on in Boston with some things in DC, and start to bring communities together. And ultimately, we ended up with some of the usual suspects. I ended up working with Tani Trivet, Senthil Mohan, and Bill McGrath, who's not here this evening, to really start thinking about how we pull together a group that creates a community around big data in DC, and then how do we connect that group with some folks in Boston who will be speaking shortly. So ultimately, what we're trying to do here is a couple things. We're just trying to inform people about what big data is and its applicability within various areas, and ultimately we're looking at interesting problems to solve, and ultimately put some interesting ideas into action as well. And you'll hear some incredible entrepreneurs who are here tonight talking about some of the things they're doing now and some of the future possibilities with big data. So I'm very excited about this, and I'm very excited about creating this community within DC. And I want to thank everyone who came here tonight, and thank our presenters. And we'll get into the details with names as towards the end of the presentation. But I just appreciate we've seen extraordinary amounts of support, and we pulled this together in a really short period of time because of the help of multiple people in this room. So which I really appreciate. So without further ado, a couple of areas that we'll talk about just before I pass this over to Chris. And I'll just give you a quick introduction to who Chris Lynch is, in case for anyone who didn't read who didn't read his bio on our site. So Chris is a technology partner at Atlas Ventures, and prior to that, he was the CEO of Vertica. In fact, that's where we met. And then prior to that, he was the CEO of Acopia, which was actually purchased by F5. So he's had quite a bit of experience in this area. So he moved from essentially large C-type roles into very much an entrepreneurial space right now. And the idea, his passion is about funding and funding some of these big data ideas and moving forward. And without further ado, let me just introduce Chris Lynch, and we'll start this off.
So how many know what big data is? Okay. How many are here for the beer?
It's too bad.
That was a trick question.
The beer comes later.
So I guess let me start with how I fell into sort of the big data space, because it's not because I was smart enough to see this mega trend happening, but let me start with a point that sort of compelled me to interest into this. Since the beginning of recorded time till 2003, 5 exabytes of data has been created by human beings. We now create that every year, every 12 months. And if you think about Moore's Law, the data generation rate today is 10 times Moore's Law annually. So the opportunity is so we have all this information, everything that's got an on-off switch is generating data, right? So you have all of this information, how do you glean any insight out of it, right? That's the opportunity. Because ultimately, more data doesn't lead to more insight, right? It leads to sort of this massive tsunami of data that you get overwhelmed with, and you sort of have analysis paralysis. So the opportunity is really to understand, how do you glean meaning from all this information? How do you harness it? How do you store it efficiently? How do you compute it? How do you transport it? But ultimately, how do you glean value from it? And I got associated with this company, Vertica, which was one of the few companies that I got involved in that I wasn't an early founder of. And I was compelled by this whole market idea around what was happening in the data space and the impact it was going to have on the market. I believe that big data is going to be bigger than and have more impact than the California gold rush, the Industrial Revolution, and the internet combined. I'm convinced of it. And it's going to transform every industry economically, and it's going to transform us socially. I know these two shy, and he would tell us how they did it, but he'd have to kill us all. But, you know, Oren was involved in a project where, you know, frankly, you know, they found Bin Laden. It was a big data play, right? There are people inventing cures for cancers, right? Identifying relationships in drug compounds. It's a big data problem. Big data is going to be at the foundation of changing everything we do. So that's what compelled me to get involved. And I met this group of MIT whiz kids at Vertica, and I was just blown away with what they were doing and the impact it could have. So that's how I sort of fell into the business. One of the things that I can tell you that's going to happen, and the speed at which it's going to happen, in the mid-90s I was part of a company called ArrowPoint. And at the time I was an executive at Lucent Technologies. They said, I'm going to leave and start this web company, and they laughed at me. They said, the web, 1996, it's a toy. The government uses it, universities use it, but it's a toy. And they literally laughed at me. They said, you're making the biggest career mistake you could ever make. You're the youngest VP at Lucent, you have an office on Mahogany Row, and your family's going to hate you forever because you're going to go and do this stupid thing and it's going to fail. And we built the product, and the first customer he had, and it reminds me of the story because it was right here, it was Unionet. And we took down a third of the internet. And I remember having a long flight back from here thinking, holy shit, Bill O'Shea was right, I'm really fucked. And, we took the product off the market, we fixed it, and we got it to work. And the first 12 months, we sold $12 million. So now we're in, I guess, 1997/98. We sold $12 million to kids with pimples on their faces. And I can remember two of those companies, and they were also down here. One was a company called MotherNature.com, which was sort of the poster child of the dot-com boom, and the other was a service provider called Servant. And I remember Servant because it was run by a young guy, and the only time we could go and upgrade the switches were like between 9 and 12 on Sundays. And you can figure out what their biggest customer was, right? They were a hoster for basically porn sites. And that was those were our customers. And we had a legion, we sold $12 million worth of kids with pimples on their faces that first year. The second year of the company, we did $250 million, and the customers were Goldman Sachs, Walmart, Staples. And those young people that engaged in those businesses were the thought leaders to apply the technology. And if you think about it today, there isn't a company that doesn't have a website, big or small, right? That doesn't have a commerce site, right? And they transformed this business. And I'd argue that, you know, Google, Facebook are the original big data companies. And that, you know, what you've seen in the last year with those companies and companies like Groupon, Groupon is sort of an unsexy couponing company that transformed their brand, although they're in some trouble now, but they transformed their brand and transformed a business leveraging big data concepts. The chief analytics officer there is actually the guy from Moneyball, the guy that built the analytics for baseball, and then he decided to apply it to a different thing. So those people are the thought leaders that are going to bring this technology to Main Street. The challenge we have is there's just not a lot of people that are smart in these concepts. So there's this tremendous market opportunity, but we're sort of meandering around and not focused on it. And from my perspective, I got into the computer business in the 80s, not because I'm not really a technical guy, and frankly, I had no ambition to be in technology. My ambition was to be a bass player in a punk rock band. But I got married, and I had a kid, and I needed a job. And at the time, mini computers were big, and Ken Olsen in Digital sort of created a business. So it was hard not to get a job in Boston in the mid-80s that wasn't in technology. So I sort of fell into it. And as I hit 50 and I think about what do I want to do sort of with the sort of sunset of my career, I want to leave Boston, the United States, and the market the way I found it, robust and vibrant. And I think that big data is going to be the platform. So that's what's in it for me. And I'm here because I want to expose as many people as possible that this opportunity is there. You have to go grab it, but it's there for you. The market is a $100 billion market today, and it's a greenfield. It's in its infancy. So it's going to be transformational. And if you walk away with anything today, at least from my piece of this discussion, it's about investigate how you dig into this because it's a jump ball. Nobody owns this. There's certainly a huge momentum advantage in the West Coast, but I can tell you the expertise that resides in the East Coast can overwhelm them if we concentrate, focus, and really take this and make it our own. And that's basically my mission. I'm going to talk a little bit about HackReduce, which is a nonprofit that I started basically to engage, educate, and innovate around big data. And my hope is that there's enough interest here that we can do a hackathon here in the coming months and create the next center for HackReduce, here in DC, because we want to bring it to places like DC, Pittsburgh, Austin, places where, people aren't waking up in the morning saying, okay, I can go start a company, right? And you can start a company, and you can make a huge contribution to the economy, to yourselves financially, and you can create not just a lot of wealth, but a huge impact. And you get inspired by something that I think can be much bigger than any of us. One of the things that I will tell you that's happening with big data, and you're going to see with this transformation, if you think about the application, so I talked to you about sort of companies like Zynga. Zynga sells virtual goods. They're an analytics company masquerading as a gaming company. They're an analytics company. And what they do is they identify, leveraging big data concepts, all the relationships and what motivates people. And they identify sort of what they call the mavens. And they can economically track, based on activities of these mavens, sort of the relationships and the economics of those relationships throughout the internet. And that allows them to charge more money for a virtual hammer than you would pay if you go to Home Depot. That's sort of the power of analytics. Think about applying that to a retail bank. Think about applying it and understanding the value and understanding relationships in drug compounds. So that the applicability, right, is across every industry, and we're really just in its infancy. So it's really, really important that you think of big data in the concept. I don't even know if we have any slides. Don't even worry about the slides. The concept you need to think about what big data is to define it. You're going to hear all the buzzwords. It's very simple. It's taking the traditionally IT optimization around information management was about optimizing the information within the four walls of a company. Big data is about optimizing the information in the four walls of the company with the information around the world and how you leverage it. So think about, if you're a product company, you have POS data, which you own. Think about taking that data and marrying it to sentiment analysis that you're getting from Facebook information, Twitter data, and putting all that together, right, to understand how do you build better products, how do you target a different constituency, how do you figure out who are your mavens, who are the people that you sell to that influence others to buy. All that is about not just the information that you have, but marrying it to the information of the world. Think about taking it and marrying it to weather-based data, understand how that affects how people act, right? GPS data, etc. That's what big data is about. It's not about, sort of just massive amounts of data. It's how do you monetize that information? How do you make it actionable? And that's about sort of reducing it to what's the 10% that really matters. And I'll give you a quick story that I think illustrates that. In a previous life, I had a customer, I'm not going to mention the name because I'm on tape, I would have, but you'll figure it out, is a jean manufacturer. And the bottom line is they sell jeans for like $300 when they're sort of in season and they're hot, and that there's a limited window. And then after that, it ends up in the off-brand retailers and they sell them for 20 bucks. So obviously their job, and what they try to do is sell as many of that inventory, as much of that inventory, at the premium price. So this marketing analyst, who was a junior marketing analyst, low-level person inside this organization, happened to go to a Lady Gaga concert with her daughter. And she saw everybody wearing these jeans with the holes in them that are $300. And she went back to the office the next day, she ran some POS data, she basically stood up an instance in the cloud of an analytic database. It was able to identify that basically 2 or 3 weeks prior and after to any place that she played around the country, they sold out all the jeans. So she went to her boss and said, you know what, we ought to basically have a truck of these jeans run through, X radius around every city that she plays in. And they went from a spoilage rate of 60% to a sale rate of 90% overnight. Now, there's no magic in that. The magic is in the democratization of data. Today, data traditionally sits in this, data warehouse, and only the sort of 1%ers get to see it. The whole idea about big data is pushing the data down to the people that actually have to take the action to run a business. And that's the power of it, right? So that's about ease of use, it's about access to the information, and it's about being able to marry data, right? Your POS data with, Twitter feeds and Facebook feeds, right? To understand, what your customers are doing, and then figuring out a way to capitalize on it. Now, could they have figured out that through traditional methods? They could have. They wouldn't have figured it out in 3 days. They would have seen that data when those jeans were already out of stock. No one cared about them. So the whole idea is to be able to get insight in time to take action on it. And that's how you monetize it. Whether it's fraud detection or, identifying, the relationships in a drug compound that can make a difference in finding a cure for something, right? Everything is about a race against time. And when you have more information, right, unless you figure out a different way to deal with it, right, you're never going to be able to, solve the problems of the world, right? So these concepts can be applied across industry, and I think that's the real power of big data. Now here's the problem. It's a $100 billion market. There are roughly 1,000 big data scientists in the world, people that are considered to be experts in big data. Now, to me, that inspires me and excites me as a capitalist, because I say, okay, I like that supply and demand. So what it should tell you is, if there's 1,000 and it's a $100 billion market, you guys are probably smarter than me, you can do that math. But it can tell you basically what you can be worth if you become an expert, not necessarily in designing all the algorithms around it, but figuring out how to harness the tools, right, to help make that data actionable. So it's a great market opportunity, whether you want to start a company, whether you want to help your company leverage big data to be relevant, or whether you want to work at a technology company that builds these things. So there's a tremendous market opportunity to take advantage of. But our problem is we don't have enough critical mass. We have the raw material, but we don't have enough people focused on it. So I don't have the slides for it, but this organization, HackReduce, the whole idea is we've brought together industry, so we have sponsorship from, matter of fact, one of our founding sponsorships is in the room here, IBM, Microsoft, Dell, I'm missing somebody, but EMC.
IBM.
I said IBM.
Okay.
But thank you for listening.
Sure.
And so we have people that are donating not just money, but their technology and their know-how to train people. So we have a curriculum. We've hired an executive director that comes from the startup program at Microsoft that ran the Nerd Center in Boston. And she's putting together the programs. We have the chair of the computer science department at MIT and Harvard working on the curriculum, as well as executives from every industry vertical. And what we're bringing together are the technologies. The thing about big data is you can't do it on a laptop. You need a 1,000-node cluster, and you need big data sets, and you need the know-how. And the whole idea of HackReduce is we're bringing all those things with a group of like-minded people. It's all in the cloud. So if you guys were inspired and I got tons of emails, we can have HackReduce here tomorrow, right? Because the technology, from IBM is in the cloud, right? So we don't need resources. What we need is a group of people that are inspired by solving problems in this area. And we can supply you with the data sets, we can supply you with the technology and the training. Some of it's vendor-based training. IBM will teach you about their technologies. EMC will do the same. Some of it is, open source stuff like Hadoop, Hive, HBase, Accumulo, any of those technologies. The whole idea is the whole thing is it's a 503c nonprofit. So so this is a total jump ball. People are doing this because we all believe that this is a technology trend that we should be in the front of. And my view is you know, we're instrumenting it in Boston because that's where I live, and I have access to all these resources, but the idea is to take that know-how and then expand it from east to west, and then ultimately to the world. But, you know, this is a technology initiative that I think we need to own. And the technology is there, the support from the vendors, you know, was tremendous. I mean, this was all put together in the last 8 weeks. And we also have matching funds from the state of Massachusetts, who, as many of you probably know, was roommates with the President of the United States. There's about $500 million in funding for big data, right? That's going to go someplace. We should make sure it goes in the direction, right, where we can be inspired and inspire people to take this technology and go solve the world's problems. You know, so it's really an opportunity for us economically and socially to be leaders. And we have so many great natural resources here, and technology people and business people. It'd be a shame if we sort of let this opportunity slip through our hands. So that's pretty much my pitch. I don't know what slides I forgot, but the other piece I would just say is, you know, with respect to a couple of the people that are here, Justin and Oren are two of my investments, my first investments in big data as a freshly minted venture capitalist. And I can tell you that I'm super excited about what they're doing, and my view is they're taking that passion and that vision around what big data can be, and they're making it happen. Justin, in addition to being named the most eligible startup bachelor in Boston, did I say he was the most eligible startup bachelor in Boston? Is the CEO of Hadapt, which is a really innovative company that I think is bridging sort of legacy database concepts with big data concepts in the analytics realm, leveraging SQL. And Oren, as I think some of you probably know, he's a local that we're sort of transplanting. And he and 6 of his buddies from the NSA who built the big data store the NSA uses in Accumulo have moved to Boston to basically build the world's most scalable, secure, and stable commercial version of Bigtable. And I think that it's going to be transformative. And we've got probably half dozen other companies like that. One other one I want to mention, because I think it's a different track that I just point out to you guys to think about, is a company called Hopper. Hopper is, if you go look it up the website, it's a travel site where it's transforming the user experience and the economics of travel, leveraging big data concepts. So they're basically trolling the web, right, for information as it relates to an experience you want, and they're doing it in split-second time. They've been developing the technology for 4 years, but it's actually, to me, represents the real future of big data, because for big data to be ubiquitous, it's got to be simpler. So we talked about democratization of data, so part of that's access to data, and then part of it is building things in such a way that it's simple enough for the broadest constituency of people to use. And that's and to me, the companies that will be successful are people that have domain expertise, and I don't care what it is, and applying big data concepts to that domain expertise to transform those industries. So to me, that's the most exciting thing about big data. And if you wrap big data, you know, if you integrate it in a storage array, you can come up with a product that will revolutionize storage. People won't know that all this big data stuff is running in the background. They don't need to know. I think that you'll also see people integrate up the stack into applications, leveraging big data concepts and data stores like Accumulo to change the way these things work. And you'll do the same thing with businesses. Those are the most exciting things from my perspective about big data. There'll definitely be infrastructure plays, but you could transform a business or a market by leveraging big data concepts. And I'll make a prediction before I sign off and let Justin jump in here. I believe in the next 18 months, you'll see every public market CEO being asked on analyst calls, what's your big data strategy? If you don't have one, you'll get knocked off, because you will no longer be competitive by efficiently managing your information. You're going to have to be able to map it to the world's information and figure out how to exploit that data. If you don't figure it out, you'll be left behind. So thanks for your time, and I'm happy to take questions at the end of the session or see you for beer later this evening. All right, thank you.
So first of all, thank you guys for having me. It's great to be here. Hadapt, just a little company background. We were founded about 2 years ago. We actually began as research in the Yale Computer Science Department. My co-founder is a professor there named Daniel Abadi, whose prior research actually led to the founding of Vertica. So a very smart, prominent researcher. I met him 2 years ago when I was actually in business school at the time, and that's how we founded the company. Since then, we've raised about $10 million in venture capital from Bessemer and Norwest. Chris is an angel investor today, but he's also the chairman of our board and certainly a tremendous mentor to me. We have 35 people. We're based in Cambridge. A little background about myself. I come from a software background. I was a developer originally for about 7 years. Worked at MIT Lincoln Laboratory, working on actually a communication satellite for the military. Then I was a product manager at a startup before going to Yale to get my MBA. And again, that's where Hadapt came from. So just a little background on some of the challenges and problems that we're trying to solve. And this is some research from Gartner in talking about the emergence of multi-structured data. So that is really to say that data, big data is not just a problem around volume, but also variety. So data is certainly growing, but it's also growing in terms of the types of data that we want to work with. And as you'll see on this chart, in fact, a lot of that data growth is actually that unstructured data, text, log files, social media, and how do I incorporate all of this to gain a better understanding of my customer? I mean, I think Chris's talk was a perfect background to really the world that we live in today, which is you've got all these data sources, and how can I leverage them to gain a competitive advantage against my competitors, whether you're a retailer, or e-tailer, a media company, a financial services company. In all these cases, you're collecting massive amounts of data points about your customers, and if you can tie these different data sources together, you can create a more holistic view of that customer, maybe market to them in a more specialized, personalized manner, and better be able to even predict their behavior. There was an interesting story in the New York Times a few months ago. This scares people sometimes about Target and how Target was sending coupons to a 15-year-old girl that had pregnancy-related products in them, things like diapers and so forth. And the father got very angry with Target. Why, how dare you send these coupons to my 15-year-old daughter? She's 15. And it turned out that Target actually knew she was pregnant before he did because of the products that she buys at Target. So, that creeps people out sometimes, but that's the power of big data, and it can be used in a lot of different ways. More specifically, the way that people are dealing with a lot of this big data is our acute friend here, Hadoop. Now, hopefully everybody here knows what Hadoop is. A quick background on Hadoop. It's an open source technology that came out of the internet companies, Facebook and Yahoo and Twitter, all use it as their data warehouse, essentially. So they store all of their data inside of this technology, which is incredibly scalable. And some of the benefits are, first of all, you don't have to throw data away anymore. You don't have to perfectly format it to fit it into a traditional data warehouse. Think of a Teradata data warehousing appliance. So you can essentially store all of that data very cost effectively in this platform. We have one customer that refers to it as a landfill. You sort of take data from all these data sources, dump it there, and you can figure out what you're looking for afterwards. So that's one benefit. It now allows you to do more advanced kind of analytics, things like machine learning with a open source technology called Mahout, or sentiment analysis, or text search, working with all these broad varieties of data inside of one platform. And then finally, not to go unstated, it's going to save you a lot of money. Rather than running a very expensive proprietary appliance, a few $1 million rack that gets wheeled in, this runs on commodity hardware, and it also runs in the cloud. So your total cost of ownership is going to be a lot lower. And we believe very strongly that this is the future of the data warehousing industry. This is the future of big data analytics. So where does Hadapt come into the picture? Well, first let's paint a picture of the typical big data analysis process. So it starts with some raw data coming in from a variety of data sources. These could be web logs, it could be email data, social media data, sensor data, documents, emails. And then you want to load that into Hadoop because of all the advantages that I mentioned. It's a great place to store data very cost effectively. And you can do some ETL processes there. So you can transform that data, extract it, prepare it, and make it ready for analysis by a business analyst. So now the challenge becomes, using Hadoop is actually very complicated. You have to know how to write MapReduce jobs. You have to be a skilled Java programmer. how does the business analyst who understands the business actually gain access to that data and gain those insights and work with it? So we need to somehow connect Hadoop, which a lot of business people have never even heard of, to the actual business analyst that knows the right questions to ask. So one thing that people in the Hadoop community will often try first is to use an open source technology called Hive, which is a SQL interface on top of Hadoop. And this was actually came out of Facebook because they wanted to use, again, Hadoop as their data warehouse. They didn't want to buy Teradata or Oracle. It would have cost them a fortune given the petabytes of data they deal with. So they built this tool called Hive, which allows you to write SQL queries. Turns out, though, that Hive is pretty immature and really lacking in a couple of dimensions. It only supports a subset of the SQL language. It's very slow. It's very batch-oriented. You have to kind of run your SQL query and then wait, a few minutes and get your response back. And it doesn't provide good connectivity to the BI tools that the business analyst is used to using. You can't just plug this into your Cognos or Business Objects or Tableau. So often, the major enterprise will then kind of give up on Hive, throw that away, and pull in a second tool, which would be an MPP database. Now, this could be any of those MPP databases that you've heard of, like Greenplums, Astrodata, Verticas, Teradata, Netezza, and you end up moving massive amounts of data, terabytes of data, into your MPP database. Of course, the MPP database is very expensive, so you were attracted to Hadoop in the first place because it's cheap, right? It runs on commodity hardware, and then you end up still spending a lot of money on this appliance to do your analytics. And of course, that allows you to actually connect to the business analyst using standard SQL, which is a language people have been using for 30 years, and BI tools, which makes this a lot more consumable. So that's the state of the art today. That's what we see a lot of with customers. What we're trying to do is actually eliminate the complexity of that whole process, contain it all within Hadoop. So Adapt is actually an analytical database that installs within your Hadoop cluster and is tightly integrated with Hadoop. We use MapReduce, we inherit the same fault tolerance, the same load balancing. All of the scalability characteristics of Hadoop are inherited by Adapt. And yet you don't have to move data around, you can access all of it within this one cluster. In addition, we make that all possible through this language that business analysts are comfortable with, familiar with, that people have been using for 30 years, and that's SQL. There's been a lot of momentum in the NoSQL community, but it turns out that again, that's catering to that 1% that Chris was talking about. What we're really trying to do is enable big data analytics to the people that actually understand the right questions to ask and who are perhaps less technically sophisticated. They're not programmers. They'd rather use a tool or familiar language. So in addition to being able to use SQL to run standard SQL queries, we actually have built in functions within SQL that allow you to do some of these more advanced analytics that you can do in Hadoop. So for example, you can do full text search through a SQL statement that we've added. You can do things like sentiment analysis. You can do things like machine learning and much more. In fact, you can imagine now within your enterprise that you do have a few of those guys that know how to write MapReduce jobs. They can actually build other user-defined functions within SQL that now the business analyst community can use. And in addition to that, again, you can plug in all of this to your favorite BI tool like Tableau to visualize this data in a very familiar and easy-to-use fashion. On a very high-level architecture view, this is essentially what we provide. I can go into much more detail for the gearheads in the room after the program. Essentially what we do is we install on that Hadoop cluster, so we're not a new Hadoop distribution. We work with MapR and Cloudera and Hortonworks, any of those Hadoop distributions. We view that as really the operating system for big data. That's the analogy that we use internally. Okay, the Hadoop cluster has that built-in fault tolerance and load balancing and resource management, those kinds of operating system-like activities. We want to be the analytic database for that operating system. In doing so, we offer this flexible query interface, allowing you to use the power of SQL to access that data. And then the real guts of what makes us different is this hybrid storage engine. And this is where it gets more technical, but I'll simply say that part of what we do is actually use relational database technology within that Hadoop cluster on each Hadoop data node. We can talk more about that afterwards if you're interested. So simply to summarize, this is an all-in-one system allowing you to capture and store and retain all of that data, structured, unstructured, that entire spectrum. Do that ETL within that cluster, do the analytics within that cluster. You don't have to move data around, and you can leverage the cost effectiveness of Hadoop. Additionally, we make it more accessible to even the business analyst who can run standard SQL queries and use standard SQL-based tools to interact with their data. And finally, we get a performance boost relative to standard Hadoop, and that has to do with that hybrid storage engine, but allows us to run much faster and much more interactively than you would get out of something like Hive. And that's derived from really database concepts that we're applying to Hadoop. So we do a lot of optimizations in that query process, co-partitioning joins, and a whole series of optimizations that give us a substantial performance boost and allow you to use Hadoop in a fashion that's much more similar to an analytic database, if that makes sense. I think that's it. So we're not doing Q&A now, right?
Why don't you Q&A at the end?
Okay.
Why don't you throw it over to Warren?
Sounds great.
Well, it's great to be here. I'm glad that Chris let me out of Boston for the day to come back to see my wife and visit my house. But so my name's Warren Falkowitz. I'm the CEO for Squirrel, and as was mentioned earlier, our team is composed of 6 folks out of the NSA who built and have contributed to the Accumulo project and have helped answer some really tough problems with big data. And we focused on a number of things, right, that really are challenging big data. The first of those being security, the second of being scalability up into the petabytes of data, and the third is providing an adaptive analytic layer that solves a series of what we'll describe as primitive analytics, and I'll give you some examples of those as we start. And so Accumulo really comes from these drivers from our government experience. When we talk about security, those are extreme security constraints that are inhibiting Fortune 500 companies and beyond today, but also that are present in the government space. The scalability is way beyond the scale that most commercial people are talking about today, and that gives us a lot of flexibility with our technology being extremely mature. And the third is this adaptability, to have a centralized data store where you can ask new questions and respond to dynamic demands without having to reinvent your processes. So what I'll do is just kind of walk you through our basic premise, and then I'd like to give you a couple interactive examples, one from Google and one that's related to Accumulo, to give you a sense of how we think about this and how we would deploy this in enterprise. So the traditional approach is that databases and data is optimized for individual business lines, right? You have your marketing data, you have your credit card transaction data, and these are individually deployed between various groups of developers and analysts on either side of this. And the common thinking is that this traditional approach, this vertical integration of your data, it reduces risk, right? It's very easy to manage, and you reduce some of the compliance and policy risks associated with your data. If you have sensitive information across one business line, you don't have to worry about sharing it across that. But this creates significant limits in your ability to respond to new demands, right? And so there's a new approach that we want to get to, right? Which is that the enterprise is much more complex than individual business lines. That you have users, you have business data, you have new sensor data, you have retailers like Walmart who want to integrate their data sets with Visa and American Express to watch transactions and watch their products fly off the shelves so they can redo stocking of products on the shelves of the supermarket, right? So you have these multiple business lines, you have these multiple data sets, and ultimately multiple applications. And what we want to do is we want to transform the relationship between data and users to make a data-centric security model. Whereas today, the relationship is tightly coupled between your database and your application. We can create a more centralized, more secure, more scalable database, and we have done this, where you can have thousands of applications that are accessing this simultaneously, right? So the fracturing of these data sets across businesses reduces capabilities, right? It reduces your ability to answer new questions dynamically. It reduces your ability to look across your data sets. It reduces your ability to bring in orthogonal data sets that can be really powerful to answer your new questions. And most importantly, it also increases the complexity, your administrative complexities, in terms of managing multiple clusters, which creates a lot of insecurity in the network, as well as it creates administrative burdens from a cost perspective as well. Right. So our approach is consolidate the data, right? Be able to look across your enterprise to see all the interesting facets that are happening across business lines. Be able to do both macro and microscopic analysis across your data, and support independent development of applications without having to tightly couple it to the data, right? But there are some challenges, right? Traditional architectures don't scale. If you want 10x performance, you need 30x compute power, and that costs you 50x, right? So this is no good, right? This is where you run into some challenges with the legacy providers. And the most important challenge in this area is that the security, the legal, the privacy, the regulatory constraints around data prevent you from bringing this together, right? So you're prohibited in some way, or if you do bring it together, then you've made those 1,000 developers that Chris talked about earlier who have this expertise, you've made those really like one person who has the right authorities and access to see the data. And yesterday I was pretty surprised when a TechCrunch article was released and Facebook did you guys see this article? Facebook had some numbers on the size of their big data, which were modestly impressive, but most importantly, the last paragraph of the article says they allow everyone to see all the data, which is a nightmare, right? And not going to be very effective if you observe what's happening in Europe and some of the trends that are coming with respect to data rights and data privacy and advocacy. Now, you can do that within single enterprises if you have your own terms of service and you control the data. But the real power, as we've been discussing, is to bring in these orthogonal data sets, and that's where these controls break down, and the need for finer grained access controls becomes critical. So Squirrel, at Accumulo, we provide this solution that drastically allows you to unlock the potential of data by atomically binding to each data element, each key value pair, visibility fields that can be infinitely expressive. Using simple Boolean language, you can say this data is for A and B or C, up to billions of potential values within each of those visibilities, right? We allow for flexible schemas, so the days of thinking about how to get your data into the system are gone, right? You can simply insert billions of records incredibly fast. The fine-grained security allows you to create secure information sharing portals. You can think of this as licensing your data to outside groups, outside vendors to create synergies that never existed before. And then most importantly, we support these data analytic primitives, basic search, go to the keyword box like at Google, type in words, graphs, right? So Accumulo is proven to do some of the biggest graphs in the world, and then statistics, right? To do a very powerful set of counting and statistics across your data that can reveal trends and anomalies that are really important. And then lastly, this reduces administrative burdens, cost efficiencies, while increasing business outputs, right, simultaneously. So what I'd like to do just quickly is give you a brief little demo. I'm just going to So the first example that I want to provide you is everyone familiar with Google Food Trends?
No.
Oh, really? Oh, that's amazing. If you're not familiar with it, right? So Accumulo is a technology that's built on Google's big table design. And so in 2003, Google started to publish a series of papers that talked about the computing architecture. The first of those papers was the Google File System, which now has Hadoop that you heard about. But then later on, they published a paper called Bigtable, which describes a key component to their architecture for long-term storage, scalable storage up into the petabytes range. And so when you interact with Google, you're interacting with Bigtable, right? You're never interacting with Hadoop, right? You are interacting with your search, with your Gmail, with Maps. It's all happening with Bigtable. Accumulo and Bigtable are the real powers, to this. And so what I wanted to just show here is here's a really great example of all the interesting things that you can find from data through a trend. So what Google has done is they've observed that at certain times there are keywords that can be indicators of the flu outbreaks, right? And you can use this to predict pandemic outbreaks. So select the country. Just go to Virginia. Right, so here's an example of, this is a very small fraction of the searches that go into Google, and they've been able to create a perfect trend with this blue line being the CDC's line for actual flu outbreaks. and they're able to predict 5 days faster than the CDC the outbreak of the flu. And the reason for this is because Google sees the searches. People start typing in like cough and sneeze and blow your nose into the web search. And then people go to their doctor, and then doctors report that to the CDC, and there's this inherent delay built into that process. And so this is exactly the kind of thing that when you have all of your data in one place, anybody can go in with an interesting idea and produce a really fascinating output that can have significant national consequences, in this case solving pandemic diseases, sometimes predicting things like outbreaks of revolutionary sentiment in countries like Egypt and Syria and other places to that effect, right? Simple trend that you can observe. So I'll show you an example of this using Cumulo. So here we built a sample application on top of Cumulo, and what I can do here is this is using Twitter data. I can type in like NHL, NFL, NBA, MLS, Olympics. Did I forget any sports, Justin?
No, looks good.
Oh, right. MLB, right?
Oh.
Or some baseball. Right. So here we have, interactive way to bring in all this data, Twitter data, and you can see clearly here this spike, the Olympics, matches perfectly with, I believe, right, Friday the 27th, opening ceremonies, right? So the power here is that when you have all this information, these types of trends provide very interesting explanations, similar to the Lady Gaga example. But most importantly, when you can apply these fine-grained security controls that we've done, you can have this extreme database where you can pull out many facets and be assured that people aren't overreaching in terms of their efforts, not seeing credit card numbers or social security numbers or other things that might be restricted, right? So, okay.
So does anyone have questions for our esteemed speakers today?
So from Accumulate to Squirrel, what's the difference? Like, what do you guys add on top of Accumulate?
Sure. Okay. So we do 3 things, right? So Cumulo is an Apache open source project, and we support the open source community. But what we try to introduce are 3 key components. The first is ease of use, right? So we want enterprises to be able to get it up and running in a short amount of time, and to have it integrated fully with all the different appliances and applications that they're running. So, Accumulo, the MapR guys, Keys in the back, they've done integrations with Accumulo, have been very successful, and we want to integrate with the suite of things that you can use, Tableau, MicroStrategy, Pentapo, et cetera, from the business side, or whatever else is lower level. The second is that we want to extend the security architecture to make that really a critical enabler for unlocking the power of information. So that includes additional authorization authentication, that includes encryption, and that includes a variety of other security features that will add over time to make data more secure and more robust. And then the third is the analytics layer that I'm sort of highlighting to you here, is that through information retrieval, through a very robust API, through statistics, through these graph properties that we'll be exposing, people will be able to transform their data in ways that they can't even imagine.
Recently, I reviewed a product for my company. Basically, it's Teradata, Aster. I think Teradata acquired Aster.
Yep.
And this,
You're right. Yep.
yeah, but the description I read is very, very similar to your product. Can you tell me how you differentiate your product to their product?
Yes, our product works. I'm serious.
That's one way. So Aster built a proprietary database effectively, right? And they implement something they call SQL MapReduce, which is a way of sort of running MapReduce from a language perspective on top of this parallel database. It does not operate on Hadoop. So there's no Hadoop in SQL and Aster, Teradata, 0 Hadoop. So why that's important is we get to benefit from everything involved with that ecosystem. So not only do we inherit technologically the ability to scale the way that Hadoop can. Aster data has never held petabyte scale data. But also we get to leverage the community of tools that people are building for Hadoop. So you can use Mahout with Adapt. You can't use Mahout with Aster. You can use all the things that that MapR and Cloudera and Hortonworks and the entire Apache community are developing for this platform. So I think they've sort of built their own implementation of MapReduce as a language to work within their proprietary closed system.
I see.
And I think that's probably the most important differentiator.
Right, and you just mentioned Mahal. I can use Mahal directly inside HBase. So why should I use your product to code Mahal? What is the advantage of doing that?
Mm-hmm. Yeah, so you can absolutely use Mahal with Hadoop. The advantage is that we're allowing you to do a lot of these things more easily using SQL. So, if you are a Java developer and you can write MapReduce jobs and you understand how to use Mahal, more power to you. But I think for the business analyst who wants to benefit from some of these things, from a business value perspective, that's really where we're trying to help them.
I see. Okay, good. Thank you.
Sure.
What company are you with?
Resonant, we are online advertisement company, so we have a lot of cookie data. And because we are pretty new and growing, so they are constantly evaluating all kinds of tools. And this is, why I'm asking is because this is for research department. For our software engineering, they don't need this really, but for research department, these analysts need something easier to do.
Exactly, yeah.
This is for anybody. Are there other advantages to the open source alternatives besides cost? So pretend for a second that money's no object and you just want data really fast and easily.
Yeah.
What are the other advantages of your guys' tools and all of that over something like Vertica? So we use Vertica right now and we love it.
Yep.
And I'm wondering what we're missing out on.
Sure. So I think it really depends on the use case and the application, but if you are working with data that is not perfectly structured, then you can't really do that in Vertica or Aster Data or any of those traditional databases. So that's another advantage of being part of the Hadoop ecosystem, which at its core is really a distributed file system. So you can store anything there. You can store photos, videos, text, anything. So I think that's one advantage. I think cost is certainly another advantage, and I think also being able to work with sort of that structured and unstructured data within one platform rather than having to move it back and forth. So I recently saw a presentation by somebody from Aster Data, and now that they've been acquired by Teradata, they had this diagram which was, you buy Aster Data, you buy Teradata's data warehouse, and you use Hadoop, and everything's connected to everything. So you need 3 things, and that becomes not only more complicated but more expensive, and you're moving data around. So part of it is also just simplification, keeping everything in Hadoop, very much similar to the model that Facebook uses.
I think Justin, the point you made also about the robust open source community, taking advantage of the intellectual capacity of thousands of people who are working on these projects independently and putting that all together. So with proprietary products, they can all of a sudden silo that to research and development of that particular organization. So.
Yep. Having said that, though, there are some use cases where Vertica is going to be fantastic. It is a high performance column store database. It's a great database. So depending on the use case, there may be some use cases where you don't need to store lots of data, you don't need to store diverse data, but you just want to benefit from that performance, that read performance. That might be a good use case. So it depends, but I think in terms of kind of building the center of your big data strategy, I think Hadoop has to be in there.
One of the things you mentioned was ETL is easy, but still in Hadoop, you're getting the data in. You still have to use from Scoop to Flume to Flame, or Flume, Flume, and all the other things to get it in. That is still a messy job to get the data in a format so we can plug it into Hadoop or get it.
Well,
do you solve that problem? Do you make that any easier?
So we don't do anything around sort of the loading of data in, but I would actually argue that it's not too hard to get it in. I think then you need to do some transformations to make the data, sort of workable. But because it's a file system at its core, you can sort of just copy stuff in there. And I think part of why that's important is that, in some cases, we've seen a lot of customers do this where they're not even sure necessarily all of the analytics they want to do on that data, but they want to make sure that they're capturing it all. Hence that landfill idea. So, Hadoop makes it easier to kind of do that and store it there cost effectively. You don't need to pay per terabyte like the MPP vendors charge. You can sort of gather it all there and then do those analytics.
Yeah, this is for anybody, but I'm coming more from a geography urban planning background, and we actually had a university consortium conference and we had big data. But one of the problems we're having is we have all this geospatial data, and we're still using traditional SQL. You know, you saw the map, it was just this very traditional map, but these processes are really dynamic over space and time. So are you guys working on tools either for visualization like cartography, maps, or queries specially designed for that yet? Or do you have plans to do it, or are we not aware of this sort of issue, I guess?
Yeah, I mean, we've come across a couple startups doing interesting things along those lines. Actually, there's one in Boston that it's called Sylvia Terra, which basically does forest inventory using satellite imagery, which is pretty cool. But anyways, to answer your question briefly, we haven't done anything in that space yet. I think it is an interesting area and maybe an area that we go at some point, but we haven't yet. Okay. I don't know if there's anything.
We've done extensive work in the geospatial realm, a lot of things with Morton curves and turning those problems into graph problems, not so much on the visual component of it, but it does we've done a number of examples like this using open layers, if you're familiar with that, which is a great geospatial visualization capability. And you know, Cumulo really is designed to be extremely flexible to do both those geospatial type queries with your structured text or unstructured data. So,
do you work in healthcare companies, please?
Do we work with healthcare companies? Sure. Blue Cross Blue Shield is probably the best example of that. Did a lot of work with them, and they actually ended up spinning out and creating sort of an analytics service bureau for all of the Blue Cross Blue Shield properties, doing everything from you know, fraud detection, which is sort of an obvious one, but the most interesting one and exciting for me is they're doing a lot. It's early days, but they're doing work around basically patient quality assurance and sort of being able to measure and predict what the outcomes are. So basically, they're monitoring when somebody goes to emergency room, sort of what treatment they get and how often they come back. Right, the goal being that you never come back, and tracking all the data so they can be prescriptive in terms of being able to have some very basic data on you and your symptoms to basically, you know, very quickly at the point of admission to determine, okay, you have, you know, one of three things, and you know, here's the most likely, you know, thing you have and the right way to treat you. But it's very interesting. I think it actually, it'll be one of those things when I was talking about sort of, you know, social impact. You know, we're not going to change sort of the supply and demand of healthcare providers and people needing healthcare. So we have to figure out a smarter way of provisioning the healthcare. And I think that, you know, big data analytics, you know, is an obvious application, which is really exciting. I think that can change the economics and the efficiency as well as the quality of healthcare.
And the next question is, do you work in genomics, something like this?
Yeah, so I mean, you're hitting sort of all the, you know, the big interesting ones that are, you know, less probably immediate impact commercially, but in terms of, like, you know, changing the quality of life in the world. Doing a lot of work with Novartis, Pfizer, Monsanto. Monsanto actually resides in our offices. We have sort of, at Atlas, we have a life sciences set of partners and a tech set of tech partners, and frankly, up until maybe a year ago, there was never any connection. Big data is now the connection. So we're literally, every company that I'm investing in, these life sciences people are looking at. So they're looking at how they're going to leverage things like Squirrel and Adapt. And we've got another one that doesn't have a formal name. We call it StatBoys, but it's sort of an automated BI tool and sort of a discovery engine that two brothers developed that were focused on going to med school. And, you know, it's a big data play, but they were using it sort of for this whole idea around, you know, how you replicate and identify relationships in data to, you know, to understand sort of, you know, drug discovery and how you can speed it up and increase the accuracy. And we think things like that, in tandem with being able to leverage security attributes of something like Squirrel. I mean, one of the challenges is that basically unfortunately, in the life sciences world, there's sets of data that they make public, which is basically the shitty data they don't care about, and the stuff that they think is going to lead to a drug discovery, they don't, provide open access to. One of the things that we're working on in sort of collaboration with multiple life sciences firms is leveraging something like Squirrel, whereby because of the security aspects of it, you could actually share the data. So for instance, some of the work they do, let's say I'm trying to develop a cure for, pancreatic cancer, right? And you're developing, I don't know, a heart disease drug. There could be sets of that data, information in that data that's relevant to both parties, and that I'd have no problem because you're not competing against me sharing, but there's no secure way to share it today, right? So the multi-tenancy and security attributes of something like Squirrel would enable that.
I just have a general question in regard to your organization. As far as the way you guys are branching out from Boston, is DC the first area that you guys are looking to build with, or like New York and Philadelphia? How is your strategy? I also would like to know how to read about the company's mission.
Yeah. Well, I was hoping to show you that, but Mark fucked up the slides. I actually had 25 slides that I worked really hard.
The top of the slide?
Yeah, absolutely. Well, if he can produce them, he probably delivered. But I'll give you a card and I'll get them to you. But we have a website, so you can find the website. But basically, the idea is, probably not New York first off, because we're trying to go to places that we think are sort of underserved, right? And where we think there's pockets of talent and interest that, are not getting mined yet. So, honestly, it's going to be based on demand. If we hear from a bunch of people that you're interested in this, and then if we stood up and did a hackathon and created this, and, people are coming and actually get engaged, we would be here, not literally tomorrow, but, by the first of the year. So it's probably going to be more demand-based. But I'd say the ones that are on my radar, for next from Boston would be DC, Pittsburgh, and Austin. But if you ask me to bet, I'm hoping that starting from today we'll start generating enough interest. I'm willing to come down here, once a month, and he's wants to see his wife. I'll probably let him do that maybe once a month or every other month. So we'll definitely have people down here that can meet people and start creating some momentum. And the other thing I'd invite anybody, the way that it's open 7x24, so you could come up and participate in a hackathon on a weekend. And there's a big network of these people, and we'd figure out a way to accommodate you and hook you up if you came to Boston and you wanted to check it out.
All right. Well, thanks everyone for coming today. This has been great. So I just want to make a couple quick points before we leave. One is, I think the most important point I want to leave you with is that since we didn't have beer at this event, we're going to invite everyone out to a local pub. Kirsten, I believe, knows where it is specifically. She'll figure it out. She can let you know. So we'll have a few beers at the end of this. So that's the critical item following this event. So I want to leave you guys with just the challenge here. So I think you've met some extraordinary people tonight, and had the opportunity to listen to them. And we want to use Big Data District to help channel that. And I said putting ideas into action. I personally have passion around healthcare, energy, mobile, and some of the security aspects. I think that's where that's my wheelhouse, and those are areas where I would like to solve some big problems with data. But I also want to hear from the community. We're creating Big Data just to be truly a community. And look, we have such an incredible, this is like an incredible opportunity here for everyone in this room and everyone that who's interested in big data to channel some of your ideas and your energy into something that's much bigger than any one of us could possibly do. So think about that very seriously, and you can email with ideas. You can contact these guys directly. We'll provide some contact details. We'll also provide the materials for this, including the slides that the actual slides that Chris was going to show. I'm sure we can provide those on a website shortly. So with that, I just want to also thank again, I have to say a few thank yous here. So if you look at the back of the room at our our team here, so we have Tanya, Kirsten, Bambi, Rebecca, and Kara have done a wonderful job this evening just hosting this event and making sure that this happened. You know, I personally couldn't have done this without their help, and they did a really tremendous job in very short notice to come in. I want to say Drew's here from Millennium Media. He's been doing some, I know he's actually specifically looking for some folks in the big data area, so he's a technical recruiter. So again, one of these opportunities, bringing people together is networking. So please, you know, he's got some actual job recs. So if you know somebody who's looking for a job, if you're interested in potential opportunities in Millennial, it's a very cool company. Please contact him. You know, well, just reach out to him. He's right there. So it's that guy.
Thank you.
So and finally, you know, I want to thank our speakers today. You know, Justin, Chris, Oren, thank you so much for taking the time today. You know, I think this has been an exceptional event. You know, I appreciate everyone coming out tonight. So thanks again, and beers.